So in this section, we are looking at applications of our primary trig ratios. So we've learned how to use sine, cosine, and tangent ratios to find angles and also to solve for missing side lengths. And this is putting it all together in section D to solve some real world problems. So our first one, we're looking at a staircase, and we have the distance between the floors is 2.5 meters. And this is also the rise of our staircase. And then the horizontal length of the staircase is 2.8 meters, and this would be the run of our staircase. So we know from grade 9 the slope, or the rate of change of the staircase, is just equal to the rise divided by the run. It's how steep it is. So slope is the same as the steepness of the staircase, and we can get that by just looking at the ratio 2.5, the rise, divided by 2.8, the run. And that will give us a decimal. If we divide 2.5 by 2.8, we get approximately a slope of 0.8929. And you could think of that ratio as a rise of 0.8929 meters for every 1 meter of run. But we can use just the decimal to represent that steepness as well, understanding that it's out of one hole. And we can rename that now using our language of trig. So we know that we are actually going to be looking at the tan ratio here, because if I look at the angle of elevation from the ground up to the top of the staircase, the rise corresponds to the opposite angle across from theta, and the run is the adjacent. And opposite and adjacent uses the tan ratio. So opposite and adjacent are just renaming the rise and the run. So tan theta is that number we just found, 0.8929. And again, that's a decimal out of one whole. To find the angle of inclination to the top of the staircase, we are just going to remember that to find an angle using our tan ratios, we start with the ratio, and to get theta on its own, the inverse operation, we need to type in second tan or shift tan on our calculator of the ratio, and that will give us back the angle. So theta is approximately 42 degrees.